So good day everyone. I am Lanurias, the first reporter of our group. So our topics is about describe basics in soil classification taxonomy. So soil taxonomy as a system of soil classification is known now as a hierarchical system having soil orders divided into suborder, grid group, subgroup, family, and series. So there are 12 orders, 64 suborders, 319 grid groups, 2,484 subgroups, and more than 8,000 families, and an unknown number of soil series. So according to Soil Survey Stat 1999, the system of soil classification used by the National Cooperative Soil Survey has 6 categories. Beginning with the broadest, these categories are the order, suborder, grid group, subgroup, family, and series. These categories are defined in the following paragraphs. So let's proceed to order. So 12 soil orders are recognized. The differences among orders reflect the dominant soil forming processes and the degree of soil information. So each order is identified with a word ending in sol, or an example is alphisols. So order is to put into a particular grouping or sequence. So it should has an ending sol. And also suborder, each order is divided into suborders primarily on the basis of properties that influence soil information and are important to plant growth. So while the grid group, each order suborder is divided into grid groups on the basis of similarities in horizon present, soil moisture or temperatures regimes, or other significant soil properties. So let's talk about the horizons present. So soil horizons differ in a number of easily seen soil properties such as color, texture, structure, and thickness. And also, most soils have 3 major horizons: the surface horizon A, the subsoil B, and the substratum C. So, while the soil moisture is the water stored in the soil and is affected by precipitation, temperature, soil characteristics, and more. While the temperature regimes, these regimes greatly affect the use and management of soils, particularly for the reflection of adapted plants. While the subgroup, each grid group has a typic or typical subgroup which is basically defined by the grid group. Other subgroups are transitions to other orders, suborders, or grid groups due to properties that distinguish it from the grid group. So, subgroup is a subset of groups elements of a group that satisfy the 4 group requirements. While the families are established within a subgroup on the basis of physical and chemical properties along with other characteristics that affect management. While the series, it consists of soils with a family that have horizons similar in color, texture, structure, reaction, consistence, mineral and chemical composition, and arrangement in the profile. So the next reporter will be discussed about the 12 soil orders. Thank you.
Good day everyone, this is Kimberlyn A. Majestrado, and for today's video, me and my group mates are going to tackle about the 12 soil orders. So the system of soil classification used by the National Cooperative Soil Survey has 6 categories. Beginning with the broadcast, these categories are the order, suborder, grade group, subgroup, family, and series. So the 12 soil orders are recognized. The differences among others reflect the dominant soil forming processes and the degree of soil formation. So each order is identified by a word ending in sol. So these are the 12 soil orders. It is alphisols, andisols, aridisols, entisols, gelisols, histosols, inceptisols, mollisols, oxysols, spodosols, ultisols, and the vertisols. Alphisols are found in cool to hot humid areas and in the semi-arid top tropics They are formed mostly under forest vegetation, but also under grass savanna. Extensive areas of alphisols are found in the Mississippi and Ohio River valleys in the USA, through Central and Northern Europe into Russia, and in the south-central region of South America. Alphisols generally show extensive profile development with distinct argillic or clay accumulations in the subsoil. Extensive leaching often produces a light-colored E-horizon below the topsoil. So alphisols are generally fine-textured soils with high base status of the humid region, so both temperate and tropical. They have accumulation of clay in the B-horizon to form argillic, candy, or natric horizon with base saturation point. So generally fertile and productive, these soils typically have a high concentration of nutrient cations and form in regions with sufficient moisture for plants for at least part of the year. Natural fertility and productive capacity of alphisols is considered to be greater than that of ultisols but less than that of mollisols. So, alphisols are moderately leached soils that have relatively high native fertility. So, these soils have mainly formed under forest and have subsurface horizon in which clays have accumulated. So, primarily, alphisols are found in temperate, humid, and subhumid regions of the world. So, alphisols are in semi-arid to most areas. These soils result from weathering processes that leach clay minerals and other constituents of the surface layer and into the subsoil, where they can hold and supply moisture and nutrients to plants. And they form primarily under forest or mixed vegetative cover and are producing for most crops. So alphisols make up about 10% of the world's ice-free land surface. Next, andisols. Soils form in volcanic ash and cinders near or downwind from volcanic activity. Generally lacking in development, they are not extensively weathered, forming in deposits from geological recent events. Usually of high natural fertility, they tend to accumulate organic matter readily and are of a light nature that is easily tilled. These soils generally have a high productivity potential. So andisols develop from andic parent materials including volcanic ash, cinders, and etc. So deposited during volcanic eruptions, andisols are young fine texture soils which have a high content of fresh weatherable minerals and a high cation exchange capacity. These soils are widely distributed in all geographical regions near sources of volcanoes. So andisols are generally fertile and are used for agricultural unless restricted by slope, altitude, soil moisture, temperature regimes, etc. Some andisols are left under tundra and forest. So andisols from weathering processes that generate minerals with little orderly crystalline structure. These minerals can result in an unusually high water and nutrient holding capacity. As a group, andisols tend to be highly productive soils. They include weakly weathered soils with much volcanic glass as well as more strongly weathered soils. They are common in cool areas with moderate to high precipitation, especially those areas associated with volcanic materials. So andisols make up about 1% of the world's ice-free land surface.
Good day everyone, my name is Polina from BSF 2A. Today, I will discuss to you our topic which is all about describe basic in soil classification taxonomy. Today, I will discuss to you my topic, which is aridisols. Aridisols are dry, desert-like soil that have low organic content and are sparsely vegetated by drought or salt-tolerant plants. Or not included in this order are soils located in polar regions or high elevation settings. Dry climate and low humus content limit their arability without irrigation. The aridisol is a layer of calcium carbonated gypsum or hydrated calcium sulfate or cemented silica is present below the surface horizon. Next is entisols. Entisols are soils of recent origin. The central concept is soils developed in unconsolidated parent material with usually no genetic horizons except an horizon. Entisols are the most extensive of the soil orders, occupying approximately 18% of the Earth's ice-free land area. The entisols are so well defined by the absence or near absence of horizons layer that clearly reflects soils forming processes. Last is gelisols. Gelisols are soil of very cold climates that contain permafrost within 2 meters of the surface. These soils are limited geographically to the high latitude polar regions and localized area at high mountain elevation.
Hello everybody, I'm Geology Gato and today I am going to report about hestisols and insectisols. Hestisols. Hestisols are soils without permafrost. So what is permafrost? Permafrost is a permanently frozen layer on or under Earth's surface. Histosols are predominantly composed of organic materials in various stages of decomposition. They generally consist of at least half organic materials by volume. They are usually saturated with water, which creates anaerobic conditions and causes organic matter accumulation and rates faster than that of decomposition. Little soil profile development is present due to their saturated and anaerobic condition. However, layering of organic materials is common. Histosols also can form in wetland areas of any climate where plants can grow such as bogs, marshes, and swamps, but are most commonly formed in cold climates. As you can see at the image above, histosols have a high content of organic matter and no permafrost. Most are saturated year-round, but a few are freely drained. Histosols are commonly called bogs, moors, pits, or mucks. Histosol from decomposed plant remains that accumulate in water, forest litter, or moss faster than they decay. If these soils are drained and exposed to air, microbial decomposition is accelerated and the soils may subside dramatically. And also, histosols are make up about 1% of the world's ice-free land surface. So, insectisols. These soils are in the beginning stages of soil profile development. The differences between horizons are just beginning to appear. Some color changes may be evident between the emerging horizons, and the beginnings of a B horizon may be seen with the accumulation of small amounts of clay, salts, and organic material. These soils show more fluvial development than antisols, but have not developed the horizons or properties that characterize other soil orders. Ancestors are commonly found throughout the world and are prominent in mountainous regions. The natural productivity of these soils varies widely and is dependent upon clay and organic matter content and other adaptive plant-related factors. Again, as you can see at the image above, ancestors are soils of semi-arid to humid environments. When we say semi-arid, it is characterized by light rainfall, while humid environments is containing or characterized by perceptible moisture, especially to the point of using of preserve, and that generally exhibit only moderate degrees of soil weathering and development. On the other hand, ancestors have a wide range in characteristics and occur in a wide variety of climates. Ancestors make up about 70% of the world's ice-free land surface.
Good day everyone, I'm Rose Missy Sala and now I will discuss about mollisols, oxysols, and spodisols. But first, let me discuss first the mollisols. The mollisols or their ticks, its name from the Latin word mollis, meaning soft. These mineral soils have developed on grassland, a vegetation that has extensive fibrous root system. The topsoil of mollisols is characteristically dark and rich with organic matter, giving it a lot of natural fertility. These soil are typically well saturated with basic cations Ce2+, Mg2+, Na+, and K+, that are essential plant nutrients. These characteristics of mollisols are placed them among the most fertile soil found in Earth. Mollisols are soils that have a dark-colored surface horizon relatively high in content of organic matter. The soils are base-rich throughout and therefore are quite fertile. Mollisols characteristically form under grass in climates that have a moderate to pronounced seasonal moisture deficit. They are extensive soil on the steppes of Europe, Asia, North America, and South Africa. So, this is the soil order of mollisols. Key characteristic: mollisols, grassland soils. Mineral soils develop under grassland vegetation. Thick, dark-colored, A-horizon, rich in organic matter. Dominant soil order of the North American Great Plains region. Large areas of mollisols are also found in Eastern Europe, Russia, China, and South America. Generally, very fertile for plant growth due to clay and organic matter content. Considered to be among the most fertile soil on Earth. And last, extent of world ice-free land area, or area 7%. Oxysols. Oxysols are the most withered of the 12 soil order in the USD soil classification system. They are composed of the most highly withered tropical and subtropical soils that are found in hot, humid climates that receive a lot of rainfall. Oxysols are located primarily in equatorial regions. These soils are extensively leached and the clay-sized particles are dominated by oxides and iron and aluminum, which are low in natural fertility. Ce2+, Mg2+, and K+, and high in soil acidity, H+, and Al3+, while oxysols are typically physically stable with low shrink swell properties and good erosion resistance. These soil require extensive inputs of lime and fertilizer to be agriculturally productive. So oxysols are highly weathered soils of tropical and subtropical regions. They are dominated by low activity minerals such as quartz, kaolinite, and iron oxides. They tend to have indistinct horizon. Oxysols characteristically occur on land surfaces that have been stable for a long time. They have low natural fertility as well as a low capacity to retain addition of lime and fertilizer. So the soil order of oxysols. Key characteristic of oxysols. The most highly weathered soils form in hot, humid climates with high annual rainfall. Commonly occur in equatorial latitudes. Highly weathered and leach, dominated by iron and aluminum oxides. Low in natural fertility, desiccation of Ce2+, Mg2+, and K+, and high in soil acidity of H+, and El3+. Physically stable soils with low shrink swell properties, and last extent of world ice-free land area of 8%. Next is the spodosol. Next is the spodosols. Spodosols are commonly formed in sandy parent materials under coniferous forest vegetation. As a consequence of their coarse texture, they have a high teaching potential. Spodosaurs are characterized by high acidity and have a subsoil accumulation of organic matter, along with aluminum and iron oxides, called a spodic horizon. Typically low in natural fertility desiccation of Ce2+, Mg2+, and K+, and high in soil acidity of H+, and Al3+. These soils require intensive inputs of lime and fertilizer to be agriculturally productive. Spodosols are commonly associated with a cold and wet climate, but also occur in warmer climates such as Florida, USA. Large areas of spodosols are found in northern Europe, Russia, and northeastern North America. Spodosols form from weathering processes that strip organic matter combined with aluminum or without iron from the surface layer and deposit them in the subsoil. In undisturbed under in undis, in undisturbed areas, a gray alluvial horizon that has the color of uncoated quartz overlies a reddish brown or black subsoil. Spodosols commonly occur in areas of coarse texture deposits under coniferous forest of humid regions. They tend to be acid and infertile. The soil order of spodosols. Key characteristic of spodosols. Form in sandy materials under coniferous forest vegetation, usually associated with the wet, cold climate. Coarse texture, high leaching potential. Have a spodic horizon composed of organic matter, Fe and El oxides. Acidic with low natural fertility. Require inputs to lime and fertilizer to be agriculturally productive. Commonly formed in North Europe, Russia, and northeastern North America. Extent of world ice-free land area is 4%.
Good morning, everyone. This is my report, Ultisols and Vertisols. What is ultisols? Ultisols are bright red, clay-rich acidic soils that previously supported a diversified forest vegetation. They are naturally suited to forestry, may be turned agricultural production, feasible with the addition of lime and fertilizers and are long-lasting building materials. What is vertisols? Vertisols are typically black in color with a wide range of organic matter content. 1 to 6%. They are rich materials like limestones and basalt, or in areas of topographic depressions where these elements are leached from uplands. Vertisols are most frequently in warm, subhumid or semi-arid regions with primarily grass, savanna, open forest, or desert shrub flora. So that's all. Thank you.